So now in this video we can go over on how we can be able to solve the equations with the radicals. Now when you hear the word radicals, what is the meaning of a radical? A radical is anything associated with a root, that is the radical. And we can have, let's say, a square root, that is the radical. We can have the cube root, that is the radical, and the fourth root, that is the radical, and whatsoever. So a radical simply means actually a root. So now in this case we should have to look at the equations with actually a square roots. Of course we have the equations with the cube roots and the fourth roots and whatsoever, but in this case we are mainly interested with solving equations. We are mainly interested with solving equations with the actually square roots. Of course, at the end of the day, this will be true for all actually equations with the different radicals. The way we are going to solve for these equations, it will also be the same way. We'll have to solve the equations with the actually radicals other than square roots. Even the cube roots, the fourth roots, whichever the root, the equations also be solved in the same way. We should have to apply in this video. So let's start it up. But the principle behind solving equations with radicals is to eliminate the radicals. So that's the principle behind. Let's say we have the equation given as square root of x minus 2 is equal to 5. So now how should we be able to solve for x in this case? So you can see that the x you are looking for, it is under actually a square root, which is the radical. So now in order to make in order to solve for x, we should have to eliminate the radical itself. So first thing, you should have to ensure that the radical expression with the radical, it is a part of the substitute formula. So in this case we are safe in the sense that the actual part with the radical, it is part of the it is substitute of the formula. Hence we are going to introduce square both sides in order to eliminate the actually square root. So in this case we have it as this one being cancelled with this one. So it is the same as x minus 2 is equal to, let's say in this case we have it as 25. You should have to understand about the working principle behind this, because the thing is that, let's say if we have a square root of, let's say a, it is the same as having it as a to the power half. Now upon introducing another actual power, let's say power 2, what happens is that this one will cancel, or only have a. So that's the working principle behind that. So keep that in mind. Now we can be able to solve for x. That will be given as x is equal to 25 plus should be 2. That is the same as 27. So the value of x is the same as 27. So that's how you should have to understand that one up to. And let's say if we have, let's say, a square root of x minus 2, and let's say is equal to, and that should be is equal to, let's say, 4. So now how should we be able to solve for x in this case? So now first thing, we should have to ensure that the expression with the radical, it is the substitute formula. So hence we have to transfer this to the other side, and that will be given as square root of x, and is equal to 4 plus 2. That will be given as the square root of x is equal, now should be 6. So we are going to introduce a square both sides. So that will be given as x is equal, now have it as 36. So that is the solution on that way. So now how about if we have, let's say, this case. Let's say we have a square of x minus 2 and the plus the square of x, let's say, plus 5. And that should be equal to 0. So how should we be able to solve for x in this case? So now we have a case whereby we have two actually expressions with the actually radicals. So now the principle behind it says that we should have to make sure to we should have to make a single radical as the subject formula. Hence, we'll have to transfer the other one to the other side. So have the square root of x minus 2 is equal to negative square root of x plus 5. And of course, plus 0 will have it as the same. Then we're going to introduce a square both sides. And that will be given as this. And hence, we'll have it as x minus 2 and is equal to. Now, since we have the single term with the radical here, notice the same as having this and having negative to the power 2. Hence, we'll have it as x, and that should be plus 5. But let's have, let's say, 2x here, and that would be much realistic. We should have 2x here, so which means we'll have 2x here. So in this case, we'll have it as 2x minus x, and that's equal to 5 plus 2. So transferring after 2 to the other side will be positive. So in that case, we'll have it as x is equal to 7. So this is the solution. So how about if we have, let's say, this other case? Let's say we have 2 and plus the square root of, let's say, x minus 5, and which is equal to, let's say, 4. So now, how should you solve for x in this case? So now, principle remains the same. We only have the single expression with the radical, so we should have to make it as the subject formula. Hence, we'll have to transfer 2 to the other side. Now that will be given as, square root of x minus 5 is equal to 4 minus 2. That will be given as x minus 5 is equal to 2. Then you can be able to solve for x in this way. And let's say we have this case. Let's say we have 2 plus square root of 2x plus 1 minus x is equal to 5. So now, how should we be able to solve for x in this case? So now, despite that we have another x here, and from the fact that we have x inside the radical, then we should have to ensure that the radical has been eliminated. So we'll have to make that one as the subject formula. Then we're going to transfer everything to the other side. That's what will happen. So which means we'll transfer x to the other side and also 2 to the other side. We'll have the square root of 2x and plus 1, which is equal to 5 minus 2 and plus x. That will have it as the square root of 2x should be the square root of 2x and plus 1, which is equal to 3 and plus x. Then now we're going to introduce a square to both sides. That will be given as 2x and plus 1 is equal. Now we'll have 3 plus x and times 3 plus x. That's how it will be. Then now we are going to expand to the other side. In the other side, that will be given as 2x plus 1 is equal to 3 times 3 is given as 9. And I'll have 3x and also have 3x and plus x squared. Then I know this is the same as having it as, now having the like terms, we'll have it as 2x plus 1, which is equal to 9 plus, let's say, 6x plus x squared. And now what is possessing it is the quadratic equation. So in this case we'll have it as x squared and plus 6x. Now let me have it in this way. In this case we'll have it as 2x plus 1 is equal to x squared plus 6x plus 9. Then now we're going to transfer the other actually terms to the other side. And that will be given as, we'll have it as 0 is equal to x squared plus 6x minus 2x and plus 9 minus 1. Of course, this is the same as x squared and plus 4x and plus 8 is equal to 0. Now we are on the page where you can be able to solve for x, either using the factor method, quadratic formula, or we can use completing square method. So can you try to check it out if the factor method can work or quadratic formula can work? Otherwise, it is possible for the equation to have no little solutions. But can you check that one out if it can work? Let's say we have, in this case, let's say we have the square of, let's say 2x plus 3 and minus, let's say 2 square of, let's say x minus 2, and which is equal to 1. So now how should we be able to solve for x in this case? So we are going to make the single radical as the substitute formula. Hence we'll have it as negative 2. So let me take it in this way. We'll have it as the square of 2x plus 3. That is equal to 1 plus 2 times the square of x minus 2. Then now we are going to introduce squared both sides. Should be square both sides. That will be given us, now we have 2x plus 3. That is equal to 1 plus 2 times the square of 2x minus 2, and the times we have 1 plus 2 times the square of x minus 2. Now we'll have 2x plus should be 3, which is equal to 1 times 1, we have it as 1. And 1 times 2 square root of 2x, up to the square root of x minus 2, we have it as 2 times the square root of x minus 2. Then this one times 1, we also have it in the same way, have it as 2 times the square root of x minus 2. Then I'll have this times this. That will be given as, we'll have it as plus, now have 4 times x minus 2. That will be given as that. Then now we have 2x plus 3. That is equal to, these are the like terms. We'll have it as, 1 plus 4 square of x minus 2. And plus 4x and the minus 8. We'll be able to expand that one. Then what go up next? Now we'll correct like terms and make any single radical which is available as the substitute formula as well. Because the core essence behind is to eliminate the radicals. So in this case we'll have it as 1 minus x should be 1 minus 8 is given as negative 7. So we have 2x and that plus 3 is equal to negative 7, and the plus 4 times the square of x minus 2 and that plus 4x. So we should have to transfer everything to the other side. In this case, negative 7 and 3 they are like terms. And also for x to the other side will also be given as, now have 2x minus 4x, and the plus 3 plus 7 is equal to 4 times the square of x minus 2. Now we have negative 2x and plus 10, which is equal to 4 times the square of 16 up to the x minus 2. Now this is the same as having as 4 times square of x minus 2, which is equal to negative 2x and that of plus 10. So that will be given as that. Then from there we are going to introduce square root both sides. And of course you may have an interest of dividing both sides by 4 to make sure that the square root is alone. But it is the same, actually it is the same way even if we can let it here because they are multiplying. But anyway, let's have to divide both sides by 4. So which means we'll have it as the square root of x minus 2, which is equal to negative 2x and plus 10 over 4. And in this case that is the same as you know that is the same as having it as square root of x minus 2, that which is equal to 10 minus 2x, that divided by 4. Then we have to introduce square both sides. In that case we have x minus 2 so have it as x minus 2, which is equal to, now this is the same as 10 minus 2x to the power 2, and that divided by 4 to the power 2. We have it as x minus 2, which is equal to, then we have 10 minus 2x and the times 10 minus 2x, which is divided by 16. And I try to have it out to solve x. And basically, whenever we are having two solutions, it is very advisable to check for the extraneous solutions. So that's what is actually being advised to. So having actually two solutions, then we'll substitute back into the original actual equation to see which solution corresponds to the actually real solution and which one corresponds to that of extraneous solutions. If the load is not checking, if the solution can't check, it means that is not the solution. Hence, it is extraneous solutions. I understand you can know that, and you know what is an extraneous solution and what is the real load. And let's say we have the square of, let's say 3 plus, that should be 2d, and plus the square of, let's say negative 1 plus, and let's say 14, that which is equal to, let's say 1. So what is the solution for this? And try to have that at your own time. And also try this one as well. Let's say have the square of 2x and minus 1, and let's say minus should be plus, so we should have it as minus here. Minus the square of, let's say x minus 2, which is equal to 2. So try to have the solution for this and check for the extraneous solutions. And how about if we have the problem with 3 radical expressions? Let's say we have the square of 2x and let's say plus 5, and which is minus the square of, let's say 8x and plus 25, and plus, let's say square of, that should be 2x and plus 8 is equal to 0. Now, how should we be able to solve for x in this case? So now principle remains the same. We'll be making the single radical as the subject formula. So in this case, we have it as the square of 2x plus 5, and which is equal to, we'll have positive 8x plus 25, and the minus square of, that is 2x plus 8 in that way. Then we have to introduce a square both sides as well. That will be given as 2x plus 5, which is equal to, then we have a square of 8x plus 25, and the minus the square of 2x plus 8, like that. Then times, now square of 8x plus 25, and the times the other. So let me have it in this way. And times, and that should be square of 8x plus 25, that is minus square of 2x plus 8. So that would be that one. Then I'll have to expand to have it as 2x, and a plus 5 is equal to, now we'll have this times this, that is the same as 8x plus 25. Then we'll have this times this, that will be given as now negative square root of 8x plus 25 and times square root of 2x plus 8. Since they are different terms, and we'll have this times this, that will be given as, should be negative, we'll have it as a negative, now should be the square root of 2x and plus 8, and the times the square root of should be 8x and plus 25. Then we have this times this, that will be given as the positive, that is 2x plus 8. That will be the way out, as you can see. Then what will go up next? So we'll have to correct up the terms together where necessary. Then we'll proceed. So in this case we have it as 2x plus 5, which is equal to, now in this case these are the like terms, so in this case we'll have to add them. We'll have negative 2 and times 8x plus 25, and also in the same square root, because although they are different terms, but they have the same radical. So times 2x plus 8, we'll have that on the start. Then plus, now we'll have 2x and plus 8. Then we'll have the like terms. In this case we'll have to transfer 2x to the other side, and that will be given as 0. Then we'll have it as 5 minus 8 is equal to, negative 2 times the square root of 8x plus 25, and the times, let's say 2x plus 8 in that case. So what is this? We have it as negative 3 is equal to negative 2 times the square root of 8x plus 25, and the times 2x and plus 8. That will be given in that case. Then we'll have to divide both sides by negative 2. So have negative 2 and also negative 2 here. So which means we'll have it as 2 should be 3 over 2, which is equal to the square root of 8x plus 25, then times 2x plus 8. Then I'll have to introduce a square both sides. That will be given as that. Then I wish to have it as this. Then I'll have it as, now we have 9 over 4, which is equal to 8x plus 25 times, now have 2x and plus 8. Now you are on the verge where you can be able to solve for x, and should it be that there will be 2 solutions, then always remember to check for the extraneous solution. And even if you can have a single solution, but you can check, because sometimes it may be that it is not the real solution. But that's the core working principle behind solving equations with radicals. Now let's say we have another case which is given as, let's say the square root of 2x, and that should be minus 3, and the minus the square root of should be 3x plus 3. Let's say this is the case, and the plus the square root of 2, actually 3x in minus 2, which is equal to 0. Should be minus 2 here. So how should you have that? You also try this at your own time. Square of, let's say, a minus x, and the plus the square of, let's say, b minus x, and is equal to, let's say we have square of a plus b minus 2x. Now, how can you be able to solve for x in that way? So try that one out at your own actually a time. And also think about this one as well, where you can have to, let's say we should have to solve for x. Let's say we have the square root of, let's say, a square of x, and the plus, let's say, square of a, and the plus the square of, that should be the square of x, and the minus the square of a, like that, and the which is equal to, let's say, the square of, 2 times the square of x, and the plus the square of, that should be 2 times the square of, and that should be b. Now solve for x in that way. So that's how you should have to understand about solving equations with radicals. And finally, let's try to have this. Let's say we have the square of x squared and the plus 3x and the minus 4, the which is minus, let's say, the square of, and that should be x squared as well, minus 5x, and let's say plus 4, and that which is equal to, let's say, x minus 1. So how can you be able to solve for that as well? And let's say you should also have to try this at your own risk. That is at your own risk, by the way. But it is something good that you should have some problems that are very complicated, but will help you to understand much. Let's say you have x squared minus x minus 1 in the minus 2 of, let's say, square of, let's say, x squared minus x and the minus 1. And try to have the solution of that. But it is something very advisable. Just have to let the expressions aside to be a certain unknown variable. Let's say a actually can be m, or whichever the variable, then you can be able to solve for x easier. But that's how you should have to understand about the solving equations with the actually radicals. And this is true for all actually radicals. So thank you for your actually moment, but don't forget to subscribe to actually this YouTube channel. Thank you.